Alright, in this problem, we are going to do more implicit differentiation. This is not just a regular implicit problem. This problem, I would like to twist your brain a little bit. So look, we got y as an independent variable and x as an independent variable. We usually do the other way around, right? We usually say x is independent, y is dependent, because the value of y depends on the value of x. But this time, we switch the role. Great. So let's see if that can train your mind a little bit. So let's write down the problem first. We have x to the fourth y squared minus x to the third times y plus 2x y to the third that is equal to 0. Since we are doing implicit differentiation, we are not wasting any energy to split the x and y. So I will just go ahead and differentiate both sides. Is that still dy dx? No, this is a dy. This time we are going to differentiate both sides with respect to y, because y is a independent variable here. Look, y is an independent variable, and then we have a dy in the denominator, so we do dy, not ddx. All right. Okay, let's see. So the first term, we have x to the 4 plus y squared. That is a product rule. I always remind my student what the product rule is. So product rule is fg prime plus gf prime, right? So the first one, we do g prime. So that is x to the 4th times 2y. Do I still need dy dx? Is this correct? The answer is no, this is wrong. The dy dx is so wrong. Let's erase this thing. We are not doing dy dx. Why? Because y is an independent variable. We take the derivative with respect to y. What's wrong with it? Nothing is wrong, right? So we don't do dy dx. And then what? And then we do the plus. And then gf prime, g is y squared. And now we are taking the derivative with respect to y of x to the 4th. What is that equal to? dy, right? So we use implicit differentiation. Let me erase the dy. So what we have to do is we bring the 4 down, and then 4 minus 1 is 3. Since you just do implicit, then you have the dx dy, not dy dx. We are trying to twist your mind a little bit. And then the next term, we have a minus. This minus is from here. We have a minus, and then fg prime, another chain rule. So fg prime, we copy f, which is x to the 3rd. The derivative of y with respect to y is 1. And then plus g, which is y, and then the derivative of x to the 3rd is 3x squared. And then what else? Since we have a dy, I just handle an x. We have to add a dx dy to it. So I am subtracting the whole thing. Don't forget your parenthesis. And then we still have a plus, so the plus goes right here. And then the f is a 2x. The derivative of y to the 3rd is 3y squared. And then plus g, which is a y to the 3rd. The derivative of 2x is 2. And then since this is x is a dependent, then we do a dx dy. And then the whole thing is equals to 0. All right, we have to open up all the parentheses and then keep dx dy on one side. So we have x to the 4th. We let the 2 go first, right? So we have 2 x to the 4th y, and then minus 4x to the 3rd y squared dy dx. No, dy dx. I already get used to it. That's why we have this problem. Dx dy. What is dx dy? Dx dy is x prime, and then minus x to the 3rd minus 3x squared y dx dy, and then plus 6x y squared, and then plus 2y to the 3rd dx dy equals to 0. Oh, okay, who needs to stay on the left? This guy, and that guy. They stay on the left. In the meantime, I will factor out dy dx dy. See, we keep doing dy dx because we get used to it. That's why we need this problem. Dx dy, and then equal, and then we inside the parenthesis we have a negative 4x to the third y squared minus 3x squared y, and then plus 2y to the third equals to, keep the rest on the left, don't forget to change the sign, plus x to the third minus 6x y squared, and then we divide both sides by that parenthesis, right? So dx dy is the same thing as x prime because we are taking the derivative of x, so that's why it's x prime. That is equal to fraction bar negative 2x to the fourth y plus x to the third minus 6x y squared divided by negative 4x to the third y squared minus 3x squared y, and then plus 2y to the third, right? So that is the answer of this problem. Okay, we have one more problem left. So that problem is a tangent line problem. Let me go ahead and paste that problem right here. So we have a tangent line problem. So use implicit differentiation to find an equation of the tangent line to the curve at the given point. So we have a equation, we have a point. Of course, to find the tangent line, tangent means we need the slope. Slope means we need to take derivative. All right, let's copy the problem first. So the problem is y times sine of 2x equals to x times cosine 2y. So first, we take derivative on both sides with respect to x. So that means we need to do a ddx on both sides. All right, and then the left side hand side is a chain rule, the right hand side is a chain rule, and a product rule. Product rule is fg prime plus gf prime. All right, so we have f g prime, so that is cosine 2x. What else? Are we done? Nope. Cosine 2x times 2. Where is the 2 came from? The 2 came from a chain rule because the derivative of 2x is equals to 2. And then we have a plus for the product rule. Gf prime sine of 2x is g, and then the derivative of f1, which is a 1, right? And then times dy dx, because you are doing with respect to x, but you have a y, that's why you have to use implicit. And then the other side, fg prime, this is f g prime, so that is what? That is negative sine of 2y. What else? The derivative of 2y is 2. So here, inside this parenthesis, what did I do? I just use a chain rule, right? And what else is missing? The missing component is a dy dx, because I have a dx right here. I'm differentiate with respect to x. However, this is a y, so I miss a dy dx inside the parenthesis. And then plus g is a cosine, and then the derivative of f is, the derivative of x is 1, so this is just a 1. Okay, we have to keep all the dy dx on one side. All right, so we have y cosine 2x 2y, and then plus sine of 2x, and then a dy dx equals to minus 2 x sine. So we have x sine of 2y, and then a plus, nope, not yet, dy dx, and then a plus cosine 2y. Okay, almost done. So we have a dy dx, because we are keeping this, and then we keep this 2. Since you move that to the left hand side, this is a sine of 2x plus 2x sine of 2y. And then the other side is cosine 2y minus 2y cosine 2x. And then the dy dx, which is a y prime. Okay, this is a y prime. That is equals to a fraction bar. We have cosine 2y minus 2y cosine 2x divided by 2x times sine of 2y, and then plus sine of 2x. So this is the derivative of the function at any point. And then what point? They are looking for a specific point, right? So this one, if just talk about the slope in general and anywhere, the slope of the curve in anywhere, this, the y prime is how we describe the slope. And then since they are using a specific point, so the point they gave us is x is equals to pi over 2, y is equals to pi over 4. All right. And then we have a y prime, or you use the dy dx, you have a cosine 2y. So 2y is a pi, 2 times pi over 4 is pi over 2, minus 2 times pi over 2y, and then cosine 2 times pi over 2 is a pi. And then divided by 2 times x, and then sine of 2 times y, and then plus sine of 2 times pi over 2 is just a pi. So we have a pi over 2, pi, and a pi, right? So at pi over 2, your unit circle, pi over 2, the coordinate is 0, 1. At pi, the coordinate is negative 1, 0, right? So just check the unit circle. You can't say you don't know. This is a topic you learn in trigonometry, unit circle. If you don't know what unit circle is, look it up online. All right, and then cosine, so y prime, the slope, cosine is refers to x, sine is referred to y. So pi over 2, we have to take the x coordinate. I made a mistake right here, right? 0, 1. I said 0, 1, but I wrote 0, 0. Cosine refers to x, so we have a 0, minus 2 times pi over 4 is pi over 2, and then cosine pi, pi is cosine refers to x, so that is multiply negative 1, and then divided by pi, sine is refers to y, so pi times 1, and then pi, y is equals to 0. So overall, what do we have? We have a pi over 2 divided by pi, that is equals to pi over 2 times the reciprocal of pi, which is 1 divided by pi. So the slope is equals to 1/2. So this is the slope of the tangent line. So that is the slope of the tangent line. At in where? The slope of the tangent line at this given point. The point they gave you has a slope equals to 1/2. And then how do you find the equation of the tangent line? You have to use a slope intercept form. Y minus y1 equals to the slope times x minus x1. So they have y minus pi over 4 equals to slope times x minus x1. So overall, this is y equals to 1/2 of x minus pi over 4 plus pi over 4. And then they just got cancelled, right? So y equals to 1/2 x. This is your tangent line. All right, that will be all in this lesson. If you think my video is helpful, give me a like, smash the subscribe or smash the like, and then share my video out. I will see you all in the next lesson.